Thanks for joining me in today's lesson. In this tutorial, we will be able to describe an arithmetic pattern and use the two arithmetic formulas. So we're in section 11.2 in our textbook, and we're talking now specifically about arithmetic sequences and series. So what it means to be an arithmetic. Now I know that this word can either be pronounced arithmetic or arithmetic, and it depends on the context. Since we're talking about sequences and series, it's pronounced arithmetic. Okay, so arithmetic sequences, each term is found by adding, notice the A, adding a constant, the same number every time. We call that constant D, and it's called the common difference. We add that constant to the previous term to get the next term. So arithmetic is adding. But again, it has to be adding the same number every time. So looking at this first example, we have 32 and then 38 and then 44. I know a few elements of a sequence is not necessarily enough to discover the pattern, but this is not too difficult to figure out. We are adding 6 and then we are adding 6 again. So this looks like an arithmetic pattern, and we can continue to add 6 to find each term. So let's talk about some of our symbols. The first symbol, or the first part, is I'm looking for a sub 1. Now sometimes it's a sub 1, sometimes for the first term you don't even see the subscript of a 1, it just says a. For every other term you definitely need the subscript. Here's a sub 6 and here's a sub 712. So these subscripts tell you which term we're talking about. So a sub 1 is as easy as just looking at the first term and saying, hey, it's a 32. Excellent. A sub 6, we need to go and find that term. Well, we have a sub 1 and a sub 2 and a sub 3. It really is only 3 more terms to go and find to find a sub 6. So I'm fine doing that. I'm going to add 6 again and get 50, and then 56, and then 62. Now, technically, what I just did is called brute force. That means that if you're just adding and adding and adding and adding, that's the slowest way to possibly find the answer. But in this case, since it's just 6 terms, I can do that pretty easily. Sometimes brute force is actually faster than using one of the formulas. Now, if I'm looking for a sub 712, the 712th term, I really am not going to want to add 6 more and more and more times. I really wish that I would have a formula to be able to plug in the 712. So that's why part C is let's discover the formula, the a sub n, the rule, like we've been talking about. So I know since I'm increasing by 6 each time, I know that 6 times n has to be part of my formula. This common difference will be a coefficient. When you're writing the rule, the common difference in an arithmetic pattern will be the coefficient. So since we're adding 6, I know that 6n has to be part of my rule. And then what I like to do is I like to plug in a 1 and see if I get my first term. So when I plug in a 1, I get 6 times 1 is 6, and that obviously is not the 32. I would need to adjust by adding 26, I believe. 6 plus 26 would make 32. Just because it works for the first term doesn't mean it works forever. So let's plug in a 2 and see if it works for the second term. 6 times 2 would be 12. 12 plus 26 is my 38. And maybe we check a random one like 5. 1, 2, 3, 4. The fifth term is 56. So if I do 6 times 5, that's 30. And 30 plus 26 is indeed the 56. So it looks like we do have the rule for any term in this sequence. So now I can plug in a 1 and get my 32. I could plug in a 6 into here and get my 62, or I could plug in my 712 and do 6 times 712 plus 26 to get what the 712th term is. When I multiply that in my head or on a calculator, you get 4,298. That's what the 712th term is. If you really were to do brute force here, I would imagine that you're going to forget your count and you'd probably either find the 711th term or possibly the 713th term, or you'd just be way off. And you would not have much time to finish the other problems on the quiz. So please make sure you understand how to use your formulas and not only by brute force. A sub 6, I'll probably use brute force. A sub 16, that's getting closer to probably using a formula. So it just really depends on which term you're looking for. So since we have a formula for the arithmetic pattern, let me give you that. It says to find the nth term, that means any term you want, for any arithmetic sequence. And that formula is a sub n. You need the first term, and you're going to add to that n minus 1 times d. This is the first of the two formulas we're going to look at in today's tutorial. So to find any specific term, you need the first term of your arithmetic sequence, you need the number of the term that you're looking for. So if you're looking for the 712th term, this would be 712, and this would be a sub 712, and you need d, the common difference. You put all that together into your formula, and you've got your whatever term you're looking for. So if I wanted to use the formula to describe a sub n, instead of using our reasoning, knowing that 6 had to be a coefficient, so we put 6n and then figure out our adjustment, I could simply say my first term, which is 32, plus n minus 1 times my d, which is 6. This is exactly the same thing. And if you don't believe me, well, do your little distributions. There's the 6n. And then we have a negative 6, and the negative 6 with the 32 makes the 26. So either one of these, of course, is acceptable if you want to do it by your logic or if you want to just plug into the formula. So here's try one. I'd like you to try this by yourself. Why don't you pause the video? I want you to find the 125th term for this arithmetic sequence. Pause now and see if you can find this answer. So thanks for trying that, and I hope that you had success. To be able to use this formula, we need a sub 1, which clearly is 16. We need to know n, which is the number of the term that I'm looking for. I'm looking for the 125th term, so n is 125. And we need to find d. It looks like we are subtracting, but arithmetic is always what we're adding. So if we happen to be going downward, then we must be adding a negative. D is a negative 9. So once I have these numbers, I just plug right into this formula. The symbol that I'm looking for is a sub 125. This should be part of your work, and that will be equal to 16 plus 125 take away 1 times my d of negative 9. Plug all that into your calculator, and you get negative 1100. And that's my 125th term. Thanks for trying that. And let's look at example 2. So example 2 says we have the fourth term is 11. And the 13th term is 65. It says write the first few terms of this sequence. And in your notes, it should say that it's an arithmetic sequence. So let's take a minute and think about this one. I think kind of drawing a picture of this might help us. Here's my first term. I don't know what it is. Here's my second term. Here's my third term. My fourth term is 11. That I know. Here's my fifth term, 6th, 7th, 8th, 9th, 10th, 11th, 12th. Here's my 13th term, and that's 65. And of course, this can continue on, I'm sure. So maybe just drawing a picture of this might help. Ultimately, we need to figure out D. If we knew what D were, then it would be pretty easy to take D. Adding D gets us up the sequence, and we could subtract D to go to the left in our sequence. So I really need to figure out what D is. Now, the brute force way would be to just guess. You could maybe, I know that since I'm going up from 11 to 65, I know that D is positive. So maybe it's a 3, maybe it's a 5, maybe it's a 10. I don't know. You could just guess. I don't want to teach you how to do it by brute force. I want to teach you how to do it mathematically so that if you have difficult numbers or if D is not actually an integer, you can figure it out. So ultimately, we need to figure out how is 11 growing all the way to get to 65. We need to figure out what that value is. the value to get from 11 all the way to 65. And that, of course, and I'm going to be dividing it by something, so that's going to be a fraction. That, of course, is the 65 take away 11. That's how much value we have, and that's 54. So we're adding 54 to get from 11 to 65, but we're going to be adding them in equal installments. So the next thing I need to figure out is how many times are we adding? Well, that's really how many spaces there are, or you could just count the commas, because we have to add once, and then 2 times, 3, 4, 5, 6, 7, 8, 9 times. So we're going to divide that into equal installments by dividing by the number of spaces, which in this case is the 13th term take away the 4th term, which is 9. This will tell us what D is. And 54 divided by 9 is 6. That's mathematically how you can always figure out what D is given any two terms of an arithmetic sequence. You take the value by subtracting backwards, and then you divide that by however many spaces there are, basically the number of terms subtracted. Do that division and you have what D is. So if D is 6, then we can simply go backwards and subtract 6 and get 5, subtract 6 and get -1, subtract 6 and get -7, and those are the first few terms. So that's a way that will always work. If some people want to figure out a different way, I don't know what this next term is. Well, now I do. I know that I'm adding 6. But if I didn't know that D were 6, I do know that this term is 11 plus whatever D is. And then this next term would be 11 plus D again, or rather 11 plus 2D. And then the next one would be 11 plus 3D. And we could keep going. Here's 11 plus 4D, 5D, 6D, 7D. Here's 11 plus 8D. So that means that one more time, 11 plus 9D would have to be the 65. So we could say 11 plus 9D has to equal 65, and that gives us an equation that we could solve for D. And if you look at this equation, think about what we're about to do. We're going to subtract 11, and there's our value, 65 take away 11, which is 54, and then we'd have to divide by D. Oops, let me change color here. We'd have to divide by D, which is exactly, excuse me, not by D, by 9, which is exactly what we did over here as well, dividing by 9, and we get that D equals 6. So that's another way to do it. It might take a little bit longer, but if you understand that, that's another way to figure out this problem. Great. Okay, the next problem, example 3, this is a pretty famous problem. It says find the sum, so now we're moving into series and adding up terms rather than the sequence which just has commas. Find the sum of the first 1,000 positive integers. So that's our goal. And no, I don't mean just get your calculator out and start plugging it in. We are ultimately adding 1 plus 2 plus 3 plus 4 plus a bunch of numbers in between, plus 997 plus 998, plus 999, plus 1,000. I understand that that's what I am adding together, but it's going to take a long time, actually not as long as you would think in the calculator, to add these together. What makes a lot more sense is grouping our terms in a better way. If you group them in order, that's probably one of the worst ways to group them. But if you group them a different way, it makes the formula that I'm about to show you a whole lot easier to remember. What I like to do is I like to take the first term and the last term and add them together. Of course, 1 plus 1,000 is 1,001. And then I take the second term and the second to last term, 2 plus 999, and guess what? I get another 1,001. I take the third term and the third to last term, 3 plus 998 gives me another 1,001, and so on and so forth. How many pairs of numbers do I have? Well, that would be 500. And what are their values always going to add to? 1,001. So there'd be 500 1,001s, which gives me a grand sum of 500,500. A much faster way of calculating this sum if you group the terms a little bit better. And I always remember this famous problem when I think about this sum formula. The second formula that we're learning today is the sum of any finite arithmetic series. Again, a series is adding terms together. Finite means that it stops. Of course, if the terms kept going, then it wouldn't have a sum. So the finite sum, and I'm going to label it as S sub n, big S, capital S, that means the sum. And the sum formula says I take the number of terms that I'm adding up and divide them in half. It's exactly how I got the 500. I had 1,000 terms and I divided it into 2. And I multiply that by the first term plus the last term, which is exactly where I got the 1,001 in the previous problem. The first term is 1. The last term is 1,000. So that's why this formula will work. And this, again, is how to find the sum of any finite arithmetic series. Now, obviously, you need some of the variables. You need to know how many terms you're adding up. You need to know what the first term is, but you also need to know what the last term that you're adding up is. Sometimes you don't know what this last, let's say we're adding up 2,000 terms, and you don't know what the 2,000th term is. You might need to use the first formula we learned today to find that 2,000th term. Then you'll have that and you can plug all into this formula and add everything up. And that's where I'd like to stop with this final try problem. It says there are 20 rows of seats in a theater. There are 25 seats in row 1, 26 seats in row 2, 27 seats in row 3, etc., etc., for 20 rows. What is the total number of seats in the theater? That's my first question. And then once you know that, if tickets cost $7.50, how much would you get for a full house? Meaning every seat is taken. So I'd like you to figure out this try problem. Pause the video. You're going to be using both formulas that we learned today and see if you can get your two answers for this. Pause now and try this on your own. So I've worked a little bit of this for you just to get you started if you're having trouble or if you want to start to check. It says there are 20 rows of seats, so that is how many terms I have. N is 20. It says 25 seats in row 1, so that is what my first term is. A sub 1 is 25. And since it goes from 25 to 26 to 27, that is an arithmetic pattern where D is equal to 1. So these are some numbers that I'm most likely going to need. I do want to know the total number of seats in the theater, so I know that I'm using my sum formula. S sub 20 would be 20 terms divided by 2 times the first term, which is 25, plus my last term, or my 20th term. That I do not know. I'm going to need to figure out that number before I can use this sum formula. So if that helps you to start to figure this out, why don't you pause again and continue. Okay, so what I needed was a sub 20, so I used my first formula from today's tutorial, and a sub 20 will be the first term, which is 25, plus 20 minus 1, that's n minus 1, times d again, which is 1. Multiplying all that together, I get 44, so that's how many seats are in the 20th row. So I put that right into my formula right there, and then I can calculate my whole sum, which was 690 seats. And so that's the first answer. And then when I multiply, of course, by 750, I get my total for a full house would be $5,175. And of course, I use my dollar sign and I use my word seats because word problems end in words. Thanks for watching this tutorial, and we'll practice with our arithmetic sequences and series in class. See ya.